Okay, and hello, and in this video, we're gonna fix a couple of issues here, the bouncing issues that for example it went through the racket, and at the top of this racket it did not bounce from the top of the racket at the ends of the racket. So I'm gonna fix the issue of end of the rackets, and then we go forward from there. So I'm gonna set it up first, this thing. Thank you. Just a moment. Okay, everything seems to be working here now. Right. Let's start. So this is how it looks now at the moment, and I can move with this guy, and and that's the racket. The red one is the racket. Yeah. So now you can see that it went through the racket already. So if this like now, it goes through the racket. The red one is the racket, and it goes through the racket. So we're gonna fix this now. I already did some research. I checked the reason, and I know now. And also the other thing is that the end of this racket here, when it hits the end of the racket, it should just bounce going that direction, the racket direction. So let us start building this program. Yes. Okie dokie. So maybe I draw it first. I draw the plan quickly here. So we have here's the racket. Here's the racket. And now the ball is coming. The ball is coming. Let's fix first the issue of the ball is hitting from ball is going this direction, for example, and then it's going here like this, because at the moment it keeps going through the racket. It doesn't bounce, and it keeps going, just sliding here, just keeps sliding here. The reason is that I only react if the ball is here. Previously we did not do anything, and because we don't do anything, nothing prevents the ball going forward from there, and all kind of weird things start happen. So I just decided that I'm gonna do the bouncing straight away here, so we don't have any problems with these heads. So what I'm gonna do now here is that, like in real life. So what should happen if this is the racket and the ball comes here and hits this end of the racket? So what should happen? Well, the ball should bounce basically the opposite direction, isn't it? I think that's a logical move here, and it's an easy move also. It's easy to go the same direction where the racket is pointing to. So I'm gonna do like that, and the same thing here. If the ball is going from here, hitting this racket, bottom of the racket, it will send the ball the opposite direction. And also, to keep it simple, even if the ball comes from here and hits this head from here, it still goes this direction. Just to keep it simple. Of course we can fine-tune this to be even better depending where it comes, but I think I already a little bit look at it, and it looks pretty good. I think it's a good logic that it always goes the racket direction if it hits this end. Okay, so let's go and do that now. First, okay, closing this one. Now let's go and look at the function which is dealing with the ball hitting the racket. ball hitting the racket, and that's gonna be which function? It's this one here, line circle collision. So let's go and see that function. What do we need to change in order to that work? So okay, so what I'm doing here is that now this is the function. So we are first checking that here, that because these are the end coordinates. This is the start coordinate of the racket, and this is the end coordinate of the racket. So we are checking that is the start point inside the circle. Is the start point inside the circle, and this one is checking that is the end point of the racket inside the circle. And if we look at the picture, so this is the situation where this is the racket and the ball is like this, or the ball is like this. Two situations. So this is what we're checking, that the end or the start of the racket is inside the ball. Okay, so we get two Boolean values, and what I'm doing here is that here I'm checking here that if it's at the end, if the circle is if the ball is inside the end or start of the racket, then I'm gonna put value in this integer. I'm gonna put 1 if it's inside the start point, and I'm gonna put 2 if it's inside the other side of the racket. And if it's not inside any, then it's 0. So this variable here has 3 values. 0 means that it's not, the ball is not inside the end points of the racket, and 1 is that it's inside the start of the racket, and 2 is that it's inside the end of the racket. So checking this value, we know that where it's located at. Okay, so now we can use that value when we are calling this function here. So I already created this integer to receive that value. Here I'm passing the pointer of that integer. So now here we need to check the integer value here, that if it's not 0, we know that the ball hit at the top of the racket, or the ball hit at the end of the racket. It hit at the end of the racket somehow. So if this value is 2, if its value is 2, then we are setting the ball direction to the racket direction. So let's say that the racket is here and this is the racket direction vector. So if the ball hits here like this, then we will go the ball direction was this way. We will simply set the ball to be the direction of the racket. So the ball goes now that direction. It goes racket direction. And here am I doing it because the racket direction is here. We calculated before this racket direction. So I'm just setting the ball go to the same direction where the racket is pointing to. And if it hit the bottom of the racket, which is which is this? Oh, there it is. So the racket is here. This is the racket, and this is the racket direction vector. So if the ball hits this one here, this bottom, and the ball was going that direction, we will bounce it the opposite of the racket direction. And actually, as I said earlier, it doesn't matter where the ball comes from. So let's say that the ball came like this, and but then goes on top of that point, we still go that direction. Okay, so let's do this. So that's why I'm setting, in that case, the direction. It will be minus the racket direction. Okay. Okay, let's see if this works. So I'm gonna run it, and I'm gonna hit at the end of the racket. I'm gonna hit the ball with the end of the rackets. End of the racket, one racket we have. So let's see what happens. Yeah, you see it's already happened. Yeah, like that. A little bit different. Yeah, like that. Did you see? So when it hits the end of the racket, it will go racket direction. Oh, yeah, like that. Yeah. So, and it works the same with the bottom of the racket. It's difficult to test here, but I already saw that before. So it all works. Yeah, like that. It hits the end of the racket, and let's see if it hits now. Yeah, hit the bottom. Yeah, did you see? It hit this one, and it bounced that way. Yep. Okay. So I will continue now. So that's the first thing to do. The second problem we have had here before was that the ball is going through the racket. Let's see that problem one more time. So if I go like this, like that, yeah, the ball goes through the racket. If this, like that, yeah, so the ball penetrates the racket like that. Yeah, it doesn't bounce. And let's see what is the reason for this. Let's see what is the reason for this. The reason the reason is that reason is, let's go and look at that function now again. Okay, let's look at these values here. Find the closest point on the line. Okay, so this is the closest x point and closest y point of the line here, when the ball is going close to the line. This is the closest x, closest y. Let's look at that. Let's look at that that thing. Yeps. Just a second. I'm thinking closest x. Yeah, that's the closest x, close. So this is the point. This is the point where it hits that line. where the ball hits that line. This is the coordinate. So if we go to the drawing board, and I will select all somehow, like, oh, select all, delete. So this is the situation now that we have the racket here. This is the racket, and then the ball is kind of hitting this like this. Now that function, those coordinates, they will give this one, this xy, this coordinate here, which is closest to the circle, like that. So that's the point. That's the point we are calculating here, the closest point to the circle. And so this is the coordinate of that point. Now, why do we need that coordinate? We need that because let's think about it. Let's think about the situation. I go back to the drawing board, and let's look at the extreme situation when it happens. Okay, now if this line is stationary, it doesn't move, not moving. If it's not moving and the ball is coming from here, let me make it bigger, the ball is coming like this, a big ball, and then it's going that direction, and then let's say that it goes a little bit like over like this, because it can a little bit penetrate that kind of thing. So now the ball needs to go that direction next. Now if this racket doesn't move, next time when we update the ball will go somewhere. The ball will go somewhere here, right? Okay, so there's no problem, and then the ball goes here, and then the ball goes here like this. So there's no problem because it bounces from the racket. But we have this problem in a case if the racket is moving also, if the racket is going down. Let's see what happens if the racket is going down. How do I draw it? Maybe I draw it here. I'll delete all of the control. Yeah. So let's look at the situation when the racket is moving down. When we saw that problem actually. So the racket is moving. The racket is moving. The racket is moving, for example, down. So let's say that the ball hits first here. I'll draw the ball. Yeah. Let's say that the ball hits here first, like this. Which is all it's okay if we just manage this situation. So then let's say that the ball came from here, and it hit the racket there. Now, so it came from here like this. So now the ball should be bouncing this direction. It should be go there. So the ball should first go. Let's say that on the next frame, the ball bounces and it goes here, right? It bounces from the racket and it goes there. This is all good. If the racket doesn't move, this all works. But the problem is that now if the racket goes down at the same time, now it's possible that if the racket is faster than the ball, it's possible that the racket actually goes there, right? So the racket is still hitting that ball. So this is the problem we are having here, that now it's again touching the racket and we get this constant problem, and now it messes up the calculations, and who knows what happens next. But this will not happen. We should never get this situation that the racket is penetrating the ball after the hit. This should never happen. What should happen is that if the racket is faster than the ball, the racket should just keep that ball in it. Like for example, if the ball comes from here, and then next the ball hits the racket, the racket going down, it should just stay there, isn't it? If the racket goes down, the ball should stay on the racket. It should never like penetrate it. So that's the first thing we need to make sure, that it should never penetrate the ball. The second thing is if the ball is faster than the this only happens if the racket is faster than the ball. Then the ball kind of stays on the racket. But if the ball is faster than the racket, then we get this situation actually. Then we get this situation. Sorry, not this situation. But then we get. We get this problem if the racket is very fast. I think this problem only comes if the racket is very fast. Let me try to prove that actually that we get the problem only if the racket is very fast. Okay, so we still have that problem. I make the racket now slower. I think it doesn't happen now if I make the racket slower. So there's the player. I'll make the player slower. Okay, so here's the speed of the player. I'll make it half of that, 150. And now the ball is faster. The ball is now 250. So the ball is faster. I don't think we get that problem now, because the ball is able to bounce a lot away from the racket. So now if I go down now, it's a bit difficult to demonstrate this. Okay, so yeah, you see. Yeah. Oh. Yeah. At least in most of the cases it seems to be now working okay. Yeah, like here. It didn't penetrate that racket. The reason is that the ball is able to bounce a lot enough from the racket, away from the racket, that we don't get the problem that it goes again through the racket. Yeah, at least it's better. And so let's now fix it totally. Let's put good logic here. So I'll make it a little bit faster. So what we need to do here now is that we need to, where is that line circle? Let me draw it here, the solution. The solution is this. The solution is this. Okay, let's draw this racket here. And let's say that the racket is going down also, no problem. Now the ball is coming from here. That direction, and then the ball next time, let's say that the ball goes here next time. Now what do we need to do here in order this working foolproof? Well, the first thing we need to do is that we need to make it so. Okay, first of all, let's understand that it should bounce there. First of all, it needs to bounce there. After it hits this, it needs to go that direction. Okay, so the first thing we need to do is that we need to adjust that ball. We need to place that ball first of all. We need to place that ball so that it's not penetrating that, not penetrating anymore that that line. So we want to place it like this. Okay. What is the benefit with this one? Well, now if the racket on the next round, if the racket moves very fast, we always have this logic now that if the ball penetrates, we will automatically move the ball at least such that it will go like this. So we have the logic here now that if the ball penetrates a little bit the racket, we will move it back to this point. Okay, so this is the point where we always move it. So if it penetrates the racket, we will immediately move it to that point where it's crossing that racket. Yeah. And now, after we did this one, now we will update everything. We will update both of them after this, after we do this. So that means that if the ball is faster than the racket, that means that on the next frame we will get like this. The ball is already out of the racket because it bounces faster than the racket is moving. But as I said, if the racket is moving faster than the ball, then it just stays on the racket like that. Okay, so okay, and there's one more thing I want to emphasize here. With the reason why this is very important, I will emphasize, because even if the ball is faster than the racket, we still might get the problem. I show you why. Even if the ball is a little bit faster than the racket, we still get the problem. Why? Because I'll show you. Let's say that the ball penetrated like this. Just an extreme situation. The ball came from here, and it went here. Virtual. It doesn't really go, but you know the program doesn't know where it's next. So the ball kind of tries to go there, and then we need to adjust the ball because it can't go there. So, but let's say that the ball is only a little bit faster than the racket. So on the next frame, now the racket is going down. So let's say that the racket goes a little bit down, like racket goes here, a little bit down, and now the ball is moving that direction. Now let's say that the ball is faster than the racket. But the problem is that if it's only a little bit faster, it will still be, you see, the ball is now faster than the racket, isn't it? But it's not enough to go out of the racket, right? So it's kind of stuck. The ball is stuck. It doesn't go out of the racket, and this is a problem. This is a problem, and we get more problems from this. There's all kind of problems coming from this. If it's not immediately able to bounce or go on the right side of the racket. So even if the ball is faster than the racket, we still might get this problem that on the next round it's still outside the inside the racket, even though it's already moving this direction, that ball. Okay, so let's fix this problem now. So what we need to do is that, as I said, one more time, I want to repeat things. So one more time. When this happens, that the ball is going, the racket is going that direction, ball hits that one. The next thing we need to do here is that we need to place immediately that ball like this, that it's touching the racket. It's out. It's not inside the racket. It's on the racket. And then we will move. Then we will go to the next step, and we will bounce the ball. And now, if the ball is faster than the racket, it will bounce off the. On the next update, it will bounce off the rackets because it's faster than the racket. Okay, so let's do that now. I'm explaining so much. Okay, so how do we do that? We do that so that we need to go to the function now. This is the function which calculates the line and circle collision stuff. So this is the closest XY. So this is the collision point. This is the collision point on the line. Remember, this is on the line. Find the closest point on the line. This is not outside the line. This is really on the line. Okay, I want to emphasize that. So that point, what we get there, it is this line point. It's on this line. It's that point over there. Okay, so we want to place that. We want to place that circle over there. It's that simple. But the problem is that this is a local variable. As you see, we are creating a float here, and the variable will get destroyed here. End of the function. So we need to save these values. Okay, we need to save these values. We need to pass them to the caller. So that's why we need to kind of get these values as output from the function. That's why I'm gonna put them here as a function arguments, both of them instead. And I put here a reference so we can get receive the values when we are calling them. We need to get those two values. So instead of creating the variables here, we will just return them because we need them. So and that's why. And let's now go to the calling side. So now here we need to create the float, two floats here to receive the collision coordinate. Okay, x and y. So this x and y is the collision point where we want to place that circle immediately. Okay, and here we are changing the ball direction. Okay, okay, and yeah, this is something else, so we don't need to go here. Forget this one. This is the section where it hits the racket. So we will immediately set the ball position to this one. So it's on the racket. Set position. And then I will set it to be on the racket. Okay, so now it's on the racket. And then the bouncing, the new bouncing direction here. And now when we update next time everything on the screen, the ball will now, it will go from the racket, not outside the racket, but from the racket it starts moving, which is much better. Okay, so let us now see what happens after this. Is it fixed now? Start. Okay. Yeah, bounce there. Yeah. You see I'm going. Yeah, you see it doesn't penetrate. Yeah, you see it doesn't penetrate. I'm good, isn't it? It doesn't penetrate anymore the racket. You see, like that. Yeah, it stopped penetrating because I'm always adjusting the ball. Yeah, you see it was on the ball. It was on the racket because that happens probably because this guy is faster than the ball, if I remember correctly. Or at least at that point. But the main thing is that it doesn't penetrate it anymore. Oh. Yeah, it's hitting the... Oh, gosh. You see, it works pretty well now. I would say. Yeah, like that. You see, it didn't penetrate the ball. Yeah, like that. Yeah. Yeah. You see. Is this good? Of course. Actually, remember we can move also other direction. I need to change this, the logic of this key actually. A little bit. It's okay for now, but it a little bit stuck because it uses the key logic. When you press the key, there's a break, but we will fine tune that the movement of this later. Yeah, you see. Okie dokie, and let me a little bit test this. I'm gonna change now the racket. This is the red one is the racket here. Let's forget this one. This is just drawing. The red one is the racket at the moment here. So I'm gonna change the angle of the racket a little bit, just to quickly test that it works. So player. I got a message from. Okay, so guys, where is the? It's here, isn't it? Yeah, here. So here is the. Please give me the racket line. Okay. So here we are doing it. So I'm gonna now make it a little bit more shallow. Sorry, a little bit more deep. So I need to make this one 150. The x coordinate of the racket needs to be plus. Let's put plus 100. So it's not so much going like not so much flat. Aha. I need to move this endpoint more up also, right? So I need to move it also more up, which is this one. So sorry, so this is right, bottom, top. Yeah. Aha. So sorry, that was the right. So this is the top. This is what we need to change also. So if I move it a little bit more top, so this needs to be smaller. Remember that the more you go up, the less the coordinate. So 0 is at the top, and 100 is below the 0. So if this is smaller, I think we get it bigger now. So yeah, it is indeed. Yeah. So okay, let me try this one. Yeah, works. Yeah. Yeah, it hit the end of the racket. Like that. Yeah. Yeah. It's like a sword, isn't it? It's like a sword. It's like a sword. Yeah, like that. Yeah. Okay. One more time. Getting excited. Oh, of course. I want to do one more hit. Yeah, that's it. Yeah, okay. I'm fine. As you can see, yeah, you see it. Those two things fixed the problems we had, and now we are in a pretty good situation now, because we have working logic for the racket. Okay, we can start now adding the racket swing. Swing. That the guy is swinging with the racket. Backhand swing. We need to get the racket moving. Okay, we need to get the racket moving, and that will be job which we need to kind of do. Okay. Is that the next thing? Sorry. Yeah, is that the next thing we want to do? I guess that's the next thing we want to do. We want to do the movement for the racket. Okay, I will tell you immediately what's my plan here. my plan is this, that ouch, all delete. Okay, this is my plan. I'm not trying to make a perfect of all of this. I'm just trying to illustrate how to create a game, you know, and all the way. I'm not gonna use too much time to make it perfect. My plan is this, that we have like four different swing states. So this is the guy. This is the guy. Like that. We are looking from the top. We're looking from the top to the bottom. So he has his hand. He has his hand here. He's doing the swing. And so this is, maybe this is his hand. And now this is his racket. This is his racket. Like this. And then I'm gonna use a different color there. I'm not gonna use red, but I'm not gonna use red for now. So this is the hitting area of the tennis racket. Here is the other hand. Okay, so this will be the tennis racket, and the hand is here obviously. And this is the first picture. The second picture, I have animation. I was thinking doing animation. So here is the second situation, and now it's kind of a little bit closer like this. Like this. And then we have the, you know what I mean? And then the next one is the maybe the straight. Totally straight. And then the next one is obviously this one, and then the next one is like this. You see what I mean? So we have like 4 different angles for this racket. So we get some kind of swing. The reason why I'm thinking doing it like this, because it's easy to do. Of course, we could do a full swing that like this. That there we don't have any steps, which would look better, right? It would look better, but I don't feel like doing it right now. It takes more time to do all of these angles. We need to calculate the angle, mathematical angles, and I'm not sure if I can do that easily. So that's why this is faster what we're doing here. So yeah, so we have, and then we have a backhand, same thing for the backhand from this side here, same thing, backhand swing. Okay, so this is what I'm aiming here. I need to have different kind of pictures for this situation. I think at the moment I'm only gonna try now I'm start doing it immediately now, but I'm not gonna draw this guy yet. I'm not gonna draw these guys. I'm only gonna draw this racket. Maybe only this red part of the racket, to be honest with you. I'm only gonna draw this red part, these 4 different 1, 2, 3. I'm gonna only draw these 4 different lines for this player. And we start from there, and later on we can make the graphic looks much better. So let me try to do this. Start doing this now. I'm doing this from the scratch, so sorry if I'm pondering too long. Okay, so how would you do that? I just started thinking it. I didn't even prepare this, by the way. Let's see if I can do this. If I can't do this, I will stop the video and do it next time. But let me try to do it straight away. So let's go to the place where at the moment the racket is here, right? At the moment we are having the racket here, right? And this is perfect in a way that it works. We already saw that the ball always, when it hits this line, it will bounce correctly. And that's a good thing. That's a good thing. So what we can do now, that we can create a class for the racket movement. We can create a class for the racket, I would say. Why not? Let's create a class for the racket, racket class, and then we tell the racket that which angle we want. Okay, we tell the racket that which one of the angles we want now, and then that class will obviously, like let's say that we tell this racket class that okay, give me angle 4. I want angle 4. It will return that line. If I say give me angle 5, it will return this line. It's that simple what I'm doing here at the first. Okay, we're just telling which line we want, and it will return that racket. I like classes, so that's why I'm gonna create a class. Add class, Visual Studio add class. The name of the class, I think a racket is a good name, right? Racket. Is it racket or racket? I think it's racket, isn't it? I keep checking this. Racket tennis. Yeah, it is racket, yeah. Okay. Press OK. Sorry. Well, the good thing with this approach is that you can have now 2 rackets. The guy can play with 2 rackets because this is a class. We can create many instances of the rackets. We can have 2 rackets and they both work. So that's the good thing with this class approach, that you can have multiple rackets, even 5 rackets at the same time. So yeah, I recommend to create classes of every new type. Just create a class. Makes life easier. It's a little bit complicated sometimes, but I think it's good. Right. Now the racket goes, first of all, the player has 1 racket, so I'm gonna go to the player, include that racket. And then the player will obviously have 1 racket. Okie doke, good start. Now I'm gonna go and look at what the racket needs. So this is the racket, right? So let's look what the racket needs. Let's look at what the racket needs. Okay. The racket needs. Now that's interesting, because are we gonna call it angle? Because a racket has different angles. How are we gonna name it? Okay, we have 5 different cases here. We have 5 different angles for the racket. Are we gonna call them angles? I think we need to have a variable called angle for the racket. What do you think? We could have actually we need 2 things. We need the angle and we need the length of the, yeah, because the length of this racket needs to be the same in all of these, so we definitely need to separate those 2. So we need to have we have angle, we have, and in this, at this moment we have only 5 different angles. Okay, and we could just call them by the index that we have, like 1, 2, 3, 4, 5, and so the angle has 5 values. Okay, if it has fixed 5 values, we could actually make them an enum also. Okay, but the problem with enum is that what if we later want much more? We want like much more of those angles. That's a good question. Enum is good, but then looking at the future, we might have like 100 different angles here. So I'm just thinking that is that a good idea to make it enum or just a number, an index number? Okay. Angle. If you put index, you can give a wrong index. Like what if I give index 8? You know what I mean? It crashes the program kind of. It's an error. You know, if I make it integer, okay, a like angle. Now, who will prevent me to put 8 there? But if it's an enum, you can't put 8. Okay. So we could start with enum, I guess. Okay. We could call it angle 1, angle 2, angle 3, angle 4, angle 5. That's my first thought. So I guess I'm gonna go with that. So enum class angle, racket angle. How about that? As I said, we're not gonna use. We cannot have any angle. We have only 5 angles. That's why I'm doing this. It's not like double angle. We can later maybe change this, but so I can say I'll just call it angle 1. I mean, hello. Oh, hello there. Yeah. Did you see the game? The game is running like this. Yeah. So. Yeah, so we run this game. Yeah, it's the angle of that racket we want to kind of, you know. Yeah. The red one is the, yeah. Aha. By the way, that ball at the bottom, why is it running like that? I need to fix that. Let me go and check if I can fix it straight away. That ball running at the bottom. Why is it running at the bottom? It's possible. Okay, it's possible it's running at the bottom because there is no. Its angle is simply, the angle is simply, you know, 9 degrees. It's just, it's exactly, the angle is exactly 90 degrees. It's possible that that's why it's running like that. So that problem might be fixed automatically when I put, you know, the fine tuning, that when it hits the wall it doesn't go, mathematically speaking, there's a little bit variation always when it hits the wall. So that automatically fixes that problem. So I'll leave that now because it's possible that there is exactly 0 angle there, 0.0000, and if that's the case, then it just keeps going, you know, horizontally all the time. So I'm not going to worry about that at the moment. So let's go now back and see the angle thing. So racket. I just call it angle 1. We can easily change these names later if we are not happy with these. Angle 2, angle 3, angle 4, and angle 5. How many? Maybe 5. And then we need to have a, so the racket needs to have the angle variable. So obviously angle, m angle, and then the racket needs to have a size, right? The racket needs to have a size. So let me go and look at it one more time. So here we are creating the racket. Yeah. Racket post start. Where does this come from? Please give me the racket. Yeah, we don't have any racket. This is the only function which is dealing with the racket at the moment, so we can do whatever we want kind of now. This is the only function at the moment dealing with the racket, so no problem, we can do whatever we want. So okay, so racket start position, direction. Why do I call it direction? This should be point. Actually, the racket should have start point and end point. Simple as that, right? Yes, this is a small mistake here. It should be not direct, but that's okay. The racket needs to have a start point. Well, it needs to have a start point and angle actually. Yeah, kind of, yeah. Now, are we going to calculate the racket automatically? You know, because are we going to calculate the length of the racket automatically? We can do that. It's not super difficult. You know, or we could just, you know, check what these values needs to be, just roughly. That's another way to do it. I'm not gonna calculate this automatically. That if we know the start point of the racket, and we know the length, then we know what is the end point, right? So it's a mathematical calculus. So if we know the start point and we know the length, then we can calculate the end point. Is that the way to go? How difficult is that? Okay, I think yes. Yeah, I can do that. I think maybe we can calculate that exactly, that the length of this line, mathematically speaking. So what we need is that we need the direction of the vector, the angle. I'm talking about the direction vector. We need the direction vector. For example, here the direction vector is this, and then we need the length L, and then we need the starting position. Okay, we need three things. We need a length of the racket. We need to know the length. Then we need to know the start point of the racket. Start point, which is the where the hand is, near where the hand is. And then thirdly, we need to know the angle. The direction vector. Direction vector of the racket. Yeah. So if we have these three, we can calculate the endpoint, mathematically speaking. And I know how to do this. So let's go and do this small exercise here. Are you ready? So this will tell what kind of angle we are interested in. Then next thing we needed was, what did we need? I keep forgetting. We need the length of the racket, right? Let it be double. So that's gonna be the length. Well, if it's a racket class, obviously length is the length of the racket, right? And the angle is the angle of the racket. You see, I don't think it's good to put racket here, by the way. That's good. That's not good naming method, because we know that now we are double length racket of the racket. That's not good, man. So let's not double the names. And then the third thing we needed here is that the direction. Okay, so now we need the direction vector. Okie dokie. And where's the direction? The direction vector was in the moving object here. Okies dokies. Now, so I need this type from here. Okay. So now the question is that, am I gonna include? So now I need to include now this moving object class, right? Here, because these structs are here. But there's a problem. The racket is not the moving object. The racket is not necessarily moving. You know, it's not. So why would the racket include also this moving object? Because it's also here. Doesn't make sense. So I think it's time to start moving this stuff to another file, which is called utilities. Let's call it utilities. Sounds good. Because this position, they have, I think it's better to separate these ones from these ones, because the other files need these ones sometimes, and they don't want this one also. So we need to kind of separate them. So I'm gonna call it utilities, add new item, and utilities, sounds good. Utilities, and then there you go. And we're gonna check those two classes over there. They are utilities classes, utility classes. Yeah, hello, Rabar, how are you? Did you follow, Rabar, did you follow previously? Let's make this game now. Let's make this game now. So direction and position go to the utilities classes file, and now we need to obviously include it here. Include utilities. Where it is? Utilities. There you go. And now that new class, racket class, also needs that, because it's gonna use the direction. So direction, and direction will be direction variable. And right, we are on a good move now. Now the next thing is that we need to return okay, and I'm gonna say, now this is an interesting, okay, so the racket, the racket actually only needs probably two, I'm going too fast, we probably actually don't need these two. Let's see. But what we really need here is that we need the starting point of the racket and the end point of the racket, right? That's all we really need here. So we need this one and this one. Those are the most important thing. We don't want to keep calculating them. We calculate them only once, and then we will keep using them as long as the angle is the same. Something like that. So I'm gonna create now the starting point and end point. They're gonna be points. So where is the utilities? So we're gonna use the position. I call it position. Okay, that's fine. Just 1 second, please. How about vector? No, it's a position, or should I say yeah, position is good. Okay, so start position and end position of the racket, right? Is it start and end, right? Sounds good. Start and end, or beginning and end. Start and, what is the best way? Beginning, start position, or start position. Okay, start position of the racket, and then we have an end position of the racket. Okay, so this is the racket. The racket describes the racket. Okay, let's continue. We need to keep moving. This is going pretty slow now, man. It's because I did not prepare. I'm doing this from the scratch, remember. Okay, so, and this is what we need to do. So I need to do this one soon, very soon. I can't be doing this 5 hours. Okay, so we need to do something like this in a moment. So what I'm gonna do next is that we need to return the start and end position somehow. Let me go and look how we use this. So I'm gonna look how we use the end and start point. Then we know how it's best to return them. Please give racket rect. Please give aha. We are using them like that, and then I'm using the values there. Okay, like that. Okay. Let's remember that the racket is defined by 2 points, right? It's always like that. It's defined by 2 points. So we could return it as a, how difficult we want to do it. We could return it as a pair, C++ pair. It's a pair of values. But then if you use pair, the problem with the pair is that then you need to use the first and second values. Maybe we can get around with that. The pair has first and second. And yeah, maybe I do that. What if I return the pair, or I'm thinking aloud. Let's remember that these are already calculated. No, we don't calculate anything here. We are just asking those values. Okay, so it's simple getter function. What on earth I'm doing? It's simple. We're just asking what is this and what is that. Simple, isn't it? So const position reference. We are pointing to this one directly with the const, meaning that we don't want to change that. So start position. Okay, and then we're just returning that, and start position return start position, and I'm gonna copy this. It's gonna be const. It doesn't change the variable, so const, put const there. It's not changing the object, and then you're gonna put start end position. End position. And that's returning the end position. Okay, this is easy, piece of cake. Okay, but now is the difficult part. When we are changing the angle and we need to calculate the angle, we need to actually calculate this to start and end position. That's the tricky part here. Okay, first of all, I think the start position normally stays the same, although if you look at the racket start position, this one here, oh no, it also changes. What am I talking about? It also a little bit changes, isn't it? Yeah, when you're swinging, the start position also moves. Yeah, of course. So we need to calculate both of them, and let's create a function for that now. So void racket. Can we call it like a swing racket? Is that a good name for the swing racket or move racket? Swing racket, position racket. What's a good name for that? When we are changing the angle of the racket, how do we call that? What's a good name for that? We could say move racket, and then we are telling which angle we move it. I start with move racket. It's not a good name, but this is not the. It's not a beautiful name, but this is not the beauty contest. This is not a beauty contest. So, okay, so move racket. Okay, and then the move racket needs an angle. We need to tell which angle you want. Okay. The angle of the racket, which will be one of these values, and then we need to pass the starting position. Do we need to pass that? This function could actually define that starting position automatically, right? Yeah, I think actually the starting point, this racket can automatically tell you where is the starting position. I think that's a good idea. So we don't pass it here. The racket will automatically define where is the starting position. Let's do like that at this point. What else we need to pass? The angle and nothing else, by the way. We might survive. We just tell that I want angle 2 and that's it. And this function is responsible for doing all of that job itself. So let's implement that function. Okay, so how do I do this? This is a difficult task now. So we need to go to that angle and put all these values, length. Aha. Okay, maybe we will create, when we create the racket, we will tell what is the length, right? Let's start like that. So when we create the object, we will tell what is the length of the racket. Okay. Racket length. Okay. When we create the racket, we will tell how long it is. What else we need to tell? At the moment, that's all we need to tell. So that's why I'm gonna just copy that length value there into that member variable. Okay. So when we create the racket, we will tell how long is the racket, and then we just tell that move the racket, and then the racket must move. Let's move the racket. Oh, this is the difficult part. Now the picture a little bit helps. Let's start from here, the number 1. Okay. So the starting position is behind the guy. Behind the guy, right? The starting position is behind somehow. So I would say now I'm gonna use, we already have tested a little bit this game, and yeps. I will look now the current situation. Let's a little bit test what are the good values. I'm gonna run this, and let's change these values and see from here actually where is a good starting position for the racket. And there's an error. Racket, no, aperture default. Yeah. We need to initialize the racket because we need to give the length of the racket when we are creating the player. So we need to initialize the the racket length, how long it will be. Let's say 60 pixels. Okay. Compile. And let's run it one more time. Let's look at the nice, okay, this is nonsense. So the racket needs to be smaller and it needs to go behind, right? So I'm gonna move that guy a little bit forward, and then we're gonna start checking what kind of racket angle and size is good. And we're gonna fix that. Yeah, that's what I'm doing at the moment. I'm sorry guys, I'm not gonna make this perfect. I'm fixing things. Maybe you said that, oh, we should accept any angle, any racket size, everything. I can't do this now. Okay, so okay, so here's the guy. I'm gonna move this guy a little bit further. Let's say 200, 150, and then the other thing I want to do is that I want to now I want to make that racket behind the guy and angle that angle behind. So so there's a, this is the player's position, the top left position of the player. But this is the bottom and this is the top. Okay, so the bottom will be sorry. So this is the width of the player. Okay. Well, I can actually draw this maybe because I'm the only guy who knows what's happening here. So let me draw this thing here. If I would, yeah, and so this is the player. At the moment, it's a bitmap, so it's not exactly the size of the player itself. The player is here, I think. Yes, the player is here in the middle of the bitmap. So this is his hair. The player is like this, and then his hand is kind of here. His hand is here. And now we want in this first situation we want to be like this. We want the racket to be like this. Okay. So this position here, this is the position of the player XY. So when I say get position, this get position is that one. It's this top left corner of this bitmap. Okay, so we kind of need to go. So we need to look at where is that start position in relation to that one. Well, it's kind of here, isn't it? I think it's 30% of the width This is the width of the rectangle. So it's kind of, I'm guessing it's like a 30%. It's this one. So let's try that. So so this is the right bottom. Okay, so this is the top. So this is the top part. So this is the bottom part. So okay, so this is the one. By the way, I'm gonna save this because maybe we need to go back to this old value. I'm gonna save it for now and make a backup copy of that. Okay, so let's try again. So the bottom, the right, yeah, right needs to be. Oh yeah, yeah, just it's 30%. Let's try that. So 0.3, that's 30%. 30% of the width of the player, okay, of the bitmap. And how about the starting position Y? Okay, let's go and look at that. Okay, well, the starting position Y, it's somewhere here, but that doesn't change much really. The Y is the same as what we did here. I said 0.5. Really? Oh, that's wrong. It should not be 0.5. That's too much because 0.5 is here. So it's more like is this like 0. It's like 30% again, isn't 35%? So I'm gonna put here 0.35%. Let me try 0.35%. And now the end point, the same thing. The right. Where's the right? Where's the X position of the end of the racket? Let's go and look at that. Well, it's very close here. It's close to the X actually, isn't it? Let's put it to the X. Agree? I put it exactly at the X. Okay. So yeah, so we remove all of that. Okay, exactly at the X, and then the Y needs to be here. So how many percentage is the Y from the height? That's like is it like 15%? Okay, am I good at estimating? So I put 15%, and now let's go look at how this looks. I'm gonna run this game and we will see that now that line there, and we will see if this is a good position. Okay. Well, we're getting there. So it's not bad start. So this is the racket at the moment, right? Well, first of all, the racket is a little bit too long, isn't it? Agree? Well, the balls are gonna be smaller. Remember that the balls are gonna be probably smaller. I'm just creating the balls big that we can see them nicely, but I think the balls are gonna be a little bit smaller in real game. So I think we can make let's make this a little bit shorter, and it can go a little bit up. Yeah, the whole thing can go a little bit up, isn't it? Because the hand is there. A little bit up and a little bit shorter. Let me try that. But other than that, it's pretty good actually. So I say I go a little bit up. So the bottom needs to go up. Let me change the length first. The length is because that's easy to. It's best to change that one first. So maybe I push the bottom Y. I push it up. If I say 30 here, and what else I had to change? Oh, it needs to go up. So the top needs to go like 0.10, something like that, and this can be even 25, I guess. So let me try now. What do you think about that? Well, if the guy is here, I think the angle is a little bit too much, because if you move the hand, it's a little bit too much in a way. Oh, well, you can, but now I need to move this a little bit. If it's that much, actually the angle is okay, I think, but we need to move it a little bit here, because the hand is gonna go from there, isn't it? So it can't be. Well, it can actually be there, because you can twist you can kind of twist your wrist to get that kind of position, isn't it? It is possible that it could be like this, the racket. Okay, I'll leave it there. And okay, let's start from there. So that will be the first angle. So let's do this. So I think what we need to do is that we need to pass this we need to pass the size of the bitmap and all these things. We need to pass the position, get this position and the size into the racket class, so that the racket can calculate all the things, right? So we need to pass them. I think so. So I'm gonna pass this get position. So that's the position of the another interesting question. We have many interesting questions here. Actually, that racket is in relation to the player, right? So if the player moves to the left, we always calculate this racket in relation to the central of the player, kind of. So so how we deal with that? We can always do so that when the player moves, when there's an update that the player moves up or down, we will always update. At that time, we will update somehow this one. Yeah, just to keep it simple. It works. I'm not saying it's the best way to do it, but it works. So we just always update it according to the, after the player moves, we will update the racket also after that. Just like that. So let's just pass the position of the player. Big const player position, and we also need the size of the player, right? So I'm using C size. Okay. I'm using C size. Oh, maybe I use the same here then. C size, which tells the size of the player. Player size, like there. Player size. And yeah. Racket angle appraisal, and that's all we need. That's all we need at this moment. So now I'm gonna copy all of that and paste it to the racket heights. Go there. We can remove the const. I don't like to have the consts here, by the way. they are optional here. So I want to keep this class as small as possible, kind of. So this is also const, by the way. And what is it complaining? It's complaining about the size, I guess. No. What is it complaining? Declaration incompatible. Incompatible. Why is that? Incompatible. Incompatible. Is it that it can't see the size, or is that the problem here? Come on. Why are you red? Oh, no, it's gone. Why is there a problem here? I'm gonna compile it. Let's see the warning. The error message. What is the error exactly? Fatal error. We have a fatal error here. Unexpected line. I think it's, why did I, but that it really needs to be there, I think. So, oh, still. Okay, so what is this error? What are you complaining now? Why you don't accept my overloaded member function not found in racket? That's not true. That's not true. This is not true. The compiler is wrong. The compiler is wrong. I did nothing wrong. Move racket. What is wrong there? Is it complaining about the consts? Are you kidding me? I don't need to put the consts here. Or do I? Oh, there's a new rule in C++ that you have. Yeah, C++ changed, I think. Because before it worked without that. I think C++ keeps changing the rules, you know. Anyway, so it needs to be exactly, okay, so const. Okay, so let's continue. Let's actually do this now. So I need to copy, I'm gonna copy all of these. And I'm gonna put that there and change it. Okay, so the position, yeah, that's gonna be the starting position. Is that the starting position? Let me put a comment here, helps us a lot. So this is the start position and this is the end position. End position. So let's go now and so there's the start position. It will be this one. Okay, and so that's the position of the player. Okay. And then the player size is here. Like that. That's working. And then we're gonna do the end position the same way. And now there's gonna be interesting thing happening in a moment. That how I'm gonna deal with the different angles, right? I will show you in a moment. I can do this. Okay, so now the interesting question is that because we're gonna pass the angle, right? So we need to draw according to the angle. This drawing here is only for the first angle, and for the next angle we need to have a different rule. So let's think about this now. So let me think how I'm gonna do this. The only thing what is changing here is the only thing what is kind of changing here is these values, 0.3, this one, and this one. Oh, what do you need? What kind of help you need? I'm at the moment I'm coding this game, but what is it? Okay, so player position X. What kind of help you need? Player position X. Okay. Just a second, let me think. Oh, okay. Also, you need to do some task. And you can email me, by the way, Tim. You can find my email. You can find my email from my channel. Just message me about. I can't do it now, but message me. We can chat about it. Okay, I continue this game now. So these are the only values what are changing here, I guess. Yeah, so this is changing, this is changing, and this, yeah, I think only these things are changing what comes to the yeah, that how many percentage we are moving according to the top left and according to the width and height of the bitmap. So what we could do here is that we could create a I can show you a trick what we can do here. We can create a map here. Okay, so we only use this once and we have a map for these 4 values. We could do like that. I'm doing it for the purpose of teaching C++ here, kind of. So I'm gonna create a map for that now. Okay, if you don't mind. So let's try that. Sometimes it goes wrong, but so I'm gonna create a map for that, and let's see if the map works nicely. So each of the angle is gonna call the map, and it's gonna ask these 4 values for that certain angle. Okay. Actually, I don't want you to do it for me. I want to do it myself to learn. Okay, Tim, send me a message. My email address can be found from my YouTube channel and from my videos. Please send me a message and let's go from there. Yeah, sounds interesting. Okay, so I'm gonna create a map for this now. Okay, guys, const std map. Okay, and what are we mapping? We are mapping these angles. Okay, and where are we mapping them to? Well, these 4 values, right? So we need to create a struct for that. Okay, struct, and let me call them position. They're the parameters for the position and size parameters for the rectangle, for the racket. Okay, so rectangle racket position and size, how do you call them? parameters. Is that a good thing? Oh, thank you very much. Oh, okay, thank you. I teach quite slowly, by the way. I'm a little bit slow sometimes. I'm trying to learn to teach a little bit faster, but just the way it goes at the moment. So racket position size parameters. They are parameters. This number here is a parameter. This is a parameter. These are parameters. They not really. They don't mean anything really to anybody. These are just. They are kind of. How do you call them? Not fraction, but what is that? When you multiply something, what is it called? Like the one in the front of the multiply. What is it? 2 multiplied by a. What is this 2? It's called. I can't get that word now. The multipliers. Multipliers, something like that. They're multipliers. Okay, so racket position size parameters. It's a long name. Okay, so racket position size parameters and product. It's something that you multiply. Yeah, but the one behind, like if you say 3 times x, what is this 3? It's something f. I can't get that. It's the factor. It's a factor, isn't it? It's a factor. Multiply factor. It's a factors, aren't they? Multiply factors. The number that we multiply are the factors of the product. So therefore 3 and 5 are the factors. Okay, so they're the factors, all right. Okay, so let me call them factors then. They are some kind of factors. Yeah. No, I'm talking about this number 3. This 3 is a factor, right? And this x is a factor. That we have 2 factors, right? 3 is a factor and this is a factor. That's what I'm talking about. I'm talking about this one. How do I call this one? This is a factor, isn't it? So, okay, I'm going to call it factor in this case. So it's gonna be so this is right. This is right. Start x. Okay, so this is start x. Okay, just a moment. Double start x factor. No, I'm looking at the factors. You multiply 2 numbers, you call two numbers, you call them factors, kind of. So start x factor. Okay, so this is the start x factor, and then this will be the start y, obviously start y factor. Okay, and this will be obviously end. So we have those factors. Not factory, but factors. So end and end. Okay, that's all we probably need here. And each angle has their own factors. That's the idea here. So I'm gonna put that. So we're mapping the angles to the factors, and then how we call this? We call map. Well, it's a global. You might want to put global because it's a global map, right? But I don't know. Just map, and then you're gonna call it. These are the angle factors. Okay, angle factors. Okay, angle factors. I think pretty good name. And then we're gonna now initialize those things. Do we need to put? Yeah. You see, now there's no red here, so that works. And now you're gonna put, the pairs here. So the first angle will be mapped to Now we need to set the factors, right? So now we need to set the factors here. Okay, so that will be simply 0.3, right? 0.3, 0.25, and then what is this? This is 0, isn't it? This is 0, right? So 0.0, and this is 0.1. And because it's an enum class, we need to put the enum name there in front of it. It's a well-defined enum. Okay, so you put like that. Okay, it's happy. And now let's run now this game, and I'm using now this map instead of this. Sorry. Okay, I'm gonna make a backup copy of this. Oh, okay, thank you for the email. Yeah. Okay, I'll check your email. Okay. I'll come back to you. I'll come back. So let me comment this out, and I'm gonna use the map now. Let's see if we get the same result. So you see, I remove those. Okay, so I'm gonna say here that multiplied by, I'm gonna put that on the next line maybe, and okay, yeah, it's late here. It's getting midnight soon here, so I'm just gonna finish this idea here. So now you take the value from the map, so you're gonna call which one you want. Well, we want the angle 1, so you're gonna put angle 1 there. And what else you need to, and then you need to say, because remember the angle 1 returns one of these struct objects, so we need to then call after that, we need to say dot, and we need to say that start x value. Okay, start x. Okay, and actually even better, we are not fixing it to angle 1, we are taking the angle from the function call, so it's whatever angle they are asking we will put there. Okay, so now this one works now for all angles. Okay, so the next one here will be and then I'm gonna put the same thing there, and that's gonna be the start y factor. And now we're gonna do the same thing here. I'm gonna say plus, and then you're gonna say player size y, and that's gonna be again we take this value from the map, so it's gonna be the end x factor. Okay, and then I'm gonna copy one more time there, and that's gonna be the end y. Okay, let's see if this works, guys. And this is very powerful now, because this code works for all angles. We don't need to add any more angle code here. We only need to fill up this map. That's all we need to do. Okay, so let's run it. If we get the same racket now, and no errors. What is it saying? I don't care about that. Okay, so let's go now and say, yeah, the racket is the same racket. Okay, going good. So let's now create the other angles. Okay, so that's the first angle, then we create another angle, and we need to now experiment a little bit. Okay, so actually we need to think now, and let's go to the drawing board. How are we gonna do this? We already talked about this before, that we need to have the starting point and then the angle. if we have the starting point and we have the angle, then we can sorry, if we have starting point and the direction vector, then we can calculate the end which is true, absolutely true, that if we have the starting point, for example here, and we know that which direction it's going, and then we also know the length, how much we need to go, then we know where it ends. Okay, I could do that. Yeah, if we do like that, then the computer automatically calculates the racket. We don't need to look at from the pictures. It's automatically, the only thing we need to say is that what is the starting point, and yeah, the only thing we need to say is where is the starting point and what is the direction vector for that racket. Okay, I think I'm gonna go there just to learn mathematics a little bit and learn programming, I guess. Let's do that. So, okay, in order to do that, we need to pass the I think we need to create another function here, void create racket by angle, create racket by angle. Okay, how about that? So we are creating the rackets here, so the computer will create the rackets. We will just tell what angle we want, and then the computer will do that for us. How about that? So we're gonna go here and we will create the racket here, and like that. So okay, so we need to pass, as I said before, we need to pass actually what happens here when we create we are creating the racket. This is the coordinate axis. Okay, when we're creating the racket, we are creating it here like this. So this is the racket. It starts from the origin because it's just a vector, mathematical direction vector. And then when we need to use it in real life, we're gonna move it there. You know what I mean? We're gonna move it to that point. So we will create it to be, we will create this racket to be from 0, always start from 0, like this. Second racket there, third racket there, fourth racket is here, and not like this. So they all are based at 0, 0. And when we are using that racket in the drawings, when you're really using that racket, you will move it there and use it there. So that's why we don't need to actually tell the position. Yeah, we don't need to know this position at this point because we always start from 0 for the racket. So we only need to tell the length and the direction. I think so. So yeah. Yes, hello. Okay, so I will go to bed now. Oh, bed. Okay, yeah, bye. Yeah, talk to you later. Okay, good night then. Yeah, the same. Okay, good night. Nice to see you. See you next time. Okay, so okay, so that's the angle we want. I think so. So that's the angle we want. And then okay, I'll check your email. Yeah, okay, sure, definitely I'll check your email. Okay, so there's the angle, and Oh, okay, okay, thanks, yeah, okay. Thanks very much. Thanks very much, yeah, thanks for the support. Okay, so there's an angle, and the other thing we need to pass is the length. There we go. So we need to pass the length in order to create that racket. So I'm gonna put that length variable there. Okay, and let's create the racket. Easier done than. In order to create the racket, we need to create the unit vector first, because we need to. The plan is here. Maybe I will delete this, or like that. Okay, so the plan is this, that this is the coordinate axis, and let's say that we want to like a racket, something like this. We want the racket like this, okay, like that kind of angle. What we do is we start from 0 the racket here, and I will first create the unit vector. The length is with the length is 1. So the length of this unit vector is 1, okay? And let's say that you are asking 5.3 length here. So we're calculating the unit vector first, and then if the length is 5.3, it's simply if this is the unit vector here, we are just multiplying the unit vector by 5.3. What am I doing? So to get this one, we will simply multiply this unit vector by 5.3, so like that, and that's how we get this one. So we will calculate the unit vector, and we get the direction, and for using that direction we will calculate the unit vector for the direction, and then we will simply multiply that, and that's how we get that endpoint. Yeah, so we need to create first the direction vector. So we create a direction vector, and then we create the unit vector of that one, and go from there. So let's say that okay, so this little bit can change now because we are using a different logic. So okay, so let's start doing this. Okay, start factor. Okay, okay, I think because the video is now getting longer, I think I'm gonna finish here. I will a little bit ponder this after the video. I will ponder this because there are a couple of ways we can go from here. So I will ponder this, and then I can fluently go next time. Okay, I'm gonna finish here and gonna continue next time. It's getting also a little bit late here, so okay, thanks, and see you next time. Let's continue from here. We will have the swing next time. Next time.